All right, so y is sine of negative x equal to the opposite of sine of x. I'm seeing a lot of explanations that include like using trig identities and things like that that go purely algebraic, but I like to look at this from the geometric perspective because that's just kind of how I think. I think of trig in circles and triangles, and so that's what we're going to do here. So let's go to the unit circle. Remember, we've got a circle of radius 1, and what does sine represent without this stuff? Sine normally means, all right, for a rotation of x degrees or radians, sine x is the y coordinate for that rotation, which really means what? It means the height. In this case, it's a positive height. And that height is, it's like 0.7 something here, right? But it's a number, and it dictates the height for a rotation of x. So when I look at sine of negative x, what is that in relation to this sine x? So sine of negative x, let's think. So what does this mean? Well, it means I'm negating my input. Negating my input, what does that mean for a sine function? Negating the input or the rotation means I'm going the opposite direction. When it's, left and right, it means we're going, left on the number line, right on the number line. When it's a rotation, it means instead of going counterclockwise, we're going to go clockwise. So this minus x, let's put it in red here, be super fancy. Means we're rotating the same amount, but instead we're rotating down x. So here's that negative x to signify that we're going this direction. All right, so then question is, what is this height here? Symmetrically, it has to be the same length of sine x. If this was 0.7, this would be 0.7. But since we're on the coordinate axis, this is a minus sine x. I'm in the negative quadrant down here, right? So this has to be negative sine x. So that's why this has to be negative sine x. That's it. Okay, purely has to do with how we've defined it, what a negative input means, and what that means for the response. So out here, this just puts us down. You can think of it as, all right, what's happening to my height if I rotate up versus rotate this way? And you can even just see, right, my hand's up versus my hand's down. So nothing too crazy. Now, I want you to pause the video and think about this question. If I take cosine and I negate it. So it means I negate the direction that I rotate. What happens? So hit pause and think about it. What's going to happen when I negate the input here? Well, if you're back, I negate the inputs. That means I can use the same picture. I rotate this way. Cos is what? Cos is the x coordinate. So that means that's this distance here. This is cos x, right? This length right here. That's cos x. And so when I negate the input, now I spin this way, and what's the x coordinate? Well, it's the same. It's the same horizontal distance from the origin, because going like this and going like this keep the tip of that ray at the same distance from the origin. So cos of negative x is cos of x. You may have seen even and odd functions in your travels. You might have even seen it in the text here. It's not something we cover extensively, but this is what it means. Or definitionally, this is what it means in general. When you negate the input and you get the same function back, the same output back, that is an even function. The sign is odd. If you negate the input, you get back the opposite. So these two are the case, and then there's also, the idea of rotations. So how about x plus 180 degrees, or x plus pi if we're in radians? Let's actually do it in radians just because that's kind of something we're learning. together here. So cos of x plus pi, what does that mean? Again, go to the graph. I honestly think if you memorize what it looks like on the circle and what the periodic graphs of sine and cosine look like, you're really not going to have that much trouble in trig, period, all the way through calculus. So, anywho, here's our circle. Remember, here's cos x. So what happens when you add 180 to x? Well, here's x. What's 180? Well, from here to here, it's a half turn of a revolution, right? So what would be 180 degrees from here? Well, it's going to be a straight line in the opposite direction. All right, so that would be something like this, where here's your 180, so that the whole thing, just to be abundantly clear, this is x plus 180, or x plus pi. I said we'll stick to radians, then didn't do that, so let's go ahead and do that. So x plus pi, this angle here is just pi. It's a half revolution. So the question is, what happens to cos x when we add pi in relation to where we started? Well, if we started up here in the first quadrant, I added 180 degrees, and now I'm down here in quadrant 3. What happens to my x coordinate, which is what cosine is? I've gone from this positive number cosine x over here to negative cosine x. So that's what this point down here, in relation to this point, has minus cos x, and then what's the sign over here as well? It's negative sine x. Right, because I'm down here in the negative quadrant. So this height and this height, or rather, yeah, this height and this length both get negated when you add 180 degrees. Okay? And you might say, well, Mal, you're keeping it easy on yourself because you're just staying in quadrant 1. That's true, but it will hold up no matter where you do it. So I'll maybe just do a quick one here. Let's draw another unit circle. Let's say my first angle out here, let's call this x, and this is cos x sine x. And then I add 180 degrees, or I add pi to that. Where do I end up? I'm going to end up down here, right? So here's x plus pi. And then what happened to my x and y coordinates? If I called this cos x and sine x before, I know this is like a negative 0.6 and a negative 0.7, or at a positive 0.7 for sine, something like that. Down here, what's it going to be? The opposite of that, right? Sine was positive, cosine was negative, and then the opposite of that will be the case over here. So if this was a negative number, negative cos will be positive, and now it's in the positive x values. If sine x was positive, now it'll be negative. Okay, so this holds up anywhere. So that's why these hold true. So cos of x plus pi is what? This is negative cos of x. Okay, it negates the normal x coordinate. And sine of x plus pi, we can do it from the same picture. What happened? I started positive, I ended negative, right? In the same direction. So from positive y to negative y. So that is why. Haha. But I hope that helps.